Hello everyone and welcome to webinar Thermal Cameras, Features and Selling Points. We're going to take a look at Metrel's newest line of instruments, the thermal cameras. I'm going to touch upon the subject of thermography, which is the science of non-contact temperature measurement, look through the camera's specifications and what sets them apart from our competitors, and finally look at their special features. I hope that by the end of the webinar, you will gain a deeper understanding of the field and our models and feel better prepared for interested customers. Now, let us begin with the definition. What is a thermal camera? It is an instrument that can sense heat or electromagnetic waves in the IR range and present them as visible light image. What is important about this to remember is that the camera does not immediately measure temperature. It measures the emitted IR waves or the emitted energy in the form of heat. The temperature is later calculated from this heat and from at least two material properties, which are emissivity and reflected heat. Uh, Emissivity is the more important and the more closely related to the material that we are measuring. And the images here are to illustrate its effect. We have three metal cups with black tape sticking to them. And in each cup, there's a water with different temperature. We can see on the IR image that there is barely a difference between cups, but there is a very clear visible difference between the tapes. This is because the metal has very low emissivity and the camera cannot really pick up its temperature, while the tape has high emissivity and therefore the camera picks up its temperature really well. The reflected heat, which I mentioned, has lower impact on the camera, on the measured temperature, but it can still distort the image, as we will see on the next slide. But firstly, we will take a very brief look at the physics. Emissivity is defined as the ratio between the perfectly emitting body, which is called a black body, and the actually emitted heat from our measured unit. It mostly depends on the material, but also partially on its color depth and the surface properties. The emissivity can be estimated to the level of low, medium, or high by looking at the object. The color depth and the surface, whether it's matte or shiny, can tell us something about the emissivity of the object. But since we usually can't tell what material it is, we can't estimate more accurately than this. For more accuracy, we have to measure the emissivity, which can be done quite easily using a dark tape and a camera, or the emissivity values can be looked up in the tables. Now, the reflected temperature is the amount of environmental heat that is reflected off the measured body. So it mostly depends on sources of heat in the environment, but also on reflectivity of the material. It has lower impact to temperature calculation, but as we can see in the images on this slide, it can distort the image. The windows in this image, they are perfectly transparent to visible light, but in the infrared spectrum, they are very reflective. Therefore, the person using the camera can be seen reflected in the window. This is a very intense, very extreme example, but almost everything reflects some amount of heat, and therefore the reflected heat has to be measured to achieve a perfectly accurate temperature calculation. Let us continue. The thermal camera is a powerful tool. Now, what makes it a powerful tool? What makes its usefulness as particularly great? It can be used to measure or calculate. I mean, I will be using the word measure here. It can be used to measure the temperature without the contact with so the person, the user, remains at the at the safe distance from any hot or cold objects. The measurement has no effect on the unit, and there is a limited ability to inspect items that are hidden from the bare eye. There is some limitation to the what I mentioned on the slide, that it works in real time. There is a slight limitation to that, and this is uh, the frame rate, the speed with which the signal from the sensor is processed to the screen. Uh, but this is still comparatively really fast when compared to the contact thermometers. So it can be considered real time. This ability, working in real time, is useful for fast inspection of units, let's say the conveyor belt, for shooting any moving units, or for shooting fast temperature changes. Now, I chose two images here that illustrate the camera's abilities. The first one is a moving belt between two gears. And if we wanted to measure the temperature of this belt with a contact thermometer, we will have to stop the gears, stop the belt, and wait for the contact thermometer to achieve the correct temperature. But with the camera, we can shoot the image and we see immediately that the belt is overheating on the inside, which means that its tightness is not optimal. On the second image, we have a trapdoor, and this image is partially also chosen so that we see the limitations of a IR-only image. Now, we can assume that we are looking at a wooden door and wooden paneling. This can be seen from the shape that we see in the scene. But why exactly do we have this coldness around the trapdoor cannot be said without extra context. Now, it could be moisture, it could be an actual spill, a water ingress, or it could be insulation that is failing. But from the sole IR image, we cannot tell which of these reasons it is. However, we can see these cool patches, which would not be visible to the naked eye, and probably are hidden behind, and the reason is probably hidden behind the paneling. So here we have both illustrated both the abilities of the camera and its limitations. The camera specifications. Now I here collected the definitions of the specifications which are hardware and cannot be later changed in a model. Later on, we will also look at some software features which can theoretically be upgraded later. Now, the first and probably most important the specification of the camera is IR sensor resolution. It means the number of points in the sensor that each can read the thermal emissions. So this is the number of points with measured temperature in the shot image. The thermal sensitivity is also sometimes called thermal resolution or noise equivalent temperature difference. Is the smallest temperature difference that the camera can tell apart, and is in a way similar to resolution in other instruments that we sell. Thermal accuracy is the average accuracy of IR sensor. Now, I talked about emissivity and reflected heat earlier, And these are two of the proper techniques that I mentioned here, and that can improve this accuracy, temperature measurement accuracy, to much better than what is specified in the single leaflet. Using these two parameters and also some others which are available in PC software, the specified the accuracy can be improved up to about 0.5%. Now, spatial resolution is the size of an actual object that fits onto a single IR pixel. It is expressed as a spatial angle in radian, or more commonly in milliradian, so that the size of the object avoids depending on distance. This is also one specification where smaller number means better specification. The frame rate, as I mentioned earlier, is the strength of the processor in the camera, or it can also mean the number of IR images that are processed from the sensor to the screen per second. Focal length is an optical specification, and it is a measure of magnification. Smaller focal length means higher magnification. This is also one of the specifications where something can be said that it is better or worse. It just means how far the camera will magnify the scene. Now, level and span are not specifications by themselves, but what is a specification is whether they can be set automatically or manually. Span is the range of temperatures in the current scene that one is shooting. It can be set automatically, which generally means everything from the lowest to the highest temperature in the scene, or it can be set by hand, which usually when setting by hand, we narrow the temperatures that are seen in the image, which improves the resolution in this thermal range, in this range that we set. Now, level is the name for the middle temperature of the span. Now, let's look briefly at the reasoning behind our line of thermal cameras. Why did we as Metrel decide to add thermal cameras to our line? Now, the cameras are useful in almost any application that other Metrel instruments support. They are a powerful troubleshooting tool, so they add the ability to locate any issue, any damage to our other instruments. And they're particularly powerful. They have a lot of applications in electrical troubleshooting or electrical diagnostics. I counted a couple of examples here. Let's say for switchboards, for bus bars, for motors, PCBs, consumer devices, for machines, for solar power. These are all cases where the Metrel instruments are used to test for safety or for functionality, but the camera can help with actually locating the problem if there is one. Additionally, since Metrel recently we recently released the catalog on building management. The cameras are can be extensively used in building management. It can help with installation diagnostics. It can help with water or gas pipes maintenance, and it can help with energy consumption management, where it actually touches also our power quality analyzer lines. The last two cases that we have, the last two examples of use, are mechanical fault finding and then general troubleshooting, let's say in service or even at home. So let us begin with overview of the models that we offer. The first one is MD9910. This is the entry-level general purpose model. I put its very fast thermal refresh rate as the first specification because I cannot stress enough how important this is. If you compare the camera with 50 hertz refresh rate to the one of the competitors' cameras, which have typically the refresh rate of about 8 or 9 hertz, you can see how much more comfortable our camera is for use. You can see the refresh rate of 9 hertz. You can see the screen stuttering or blinking. But with 50 hertz, you can move the camera as fast as you want and you will not see the screen stutter. So it means both much higher comfort, much easier use, but also higher refresh rate means the ability to detect, let's say, some rare thermal events or fast thermal changes. The temperature range in this camera is quite high. It goes from -20 to 380 degrees, which also reaches the temperatures needed to work in, let's say, in industrial setting. The size of the thermal sensor is 80 times 80 pixels, which is quite good for this price range, but nothing exceptional. The thermal sensitivity of 0.1 degrees Celsius at 30 degrees, you will notice that it is always defined at 30 degrees Celsius. This is a pretty standard specification, it's nothing special. Similarly, is true of the thermal accuracy, plus minus 2 degrees or plus minus 2%, whichever is higher. But as I mentioned earlier, and this is the specified is the average accuracy. However, it can be improved by using them by setting emissivity and reflected temperature or reflected heat correctly, and it can reach in this case. Then the camera only supports setting emissivity, so it can be improved from this to 2 degrees a little, but not very much. Field of view is 91 degrees times 91 degrees. And this is one of the specifications that cannot be good or bad. It just means whether it's more general purpose or more narrow purpose. And 21 times 21 degrees is a pretty general purpose field of view. It can be used in almost any application. The spatial resolution essentially follows from the field of view and the IR resolution. And in this case, it is actually quite good for this price range. The spectral range, 8 to 14 micrometers, means that the camera can sense the whole IR spectrum. The 8 and 14 micrometers are the limits of the electromagnetic spectrum that we consider infrared. Now, focal length for this camera is 7.5 millimeters, which is a bit on the small side. So this camera magnifies the scene quite a lot. You will also notice that in thermal cameras, the focal length is typically much shorter than in visible light cameras. So 7.5 millimeters would be a very, very small focal length for, the regular camera, for the art camera. But for thermal camera, it is not untypical. The screen resolution is 240 times 320 pixels. And this is very typical screen resolution. The reason I put it here is that some of our competitors are really in habit of putting this resolution on top. and saying that since the firmware upscales the image from the sensor to the screen, this is now the thermal resolution, which isn't true. The thermal resolution is exactly the size of the thermal sensor. There are no additional points of temperature measurement made just because the image is upscaled to the screen resolution on the camera. The focus on this camera is fixed, which means that the whole time the whole image is sharp. Now, this is in a way good because it is easy to use. However, the settable focus, the manually settable focus, is more of a professional feature which enables the user to separate objects at one distance from foreground and background. So only the objects at a certain distance are sharp or are actually in focus, while anything before them and after them is not. The 2-meter drop test is necessary for handheld items, for handheld instruments, and it means what it says. It was tested to survive the drop from 2 meters. Now, about the automatic and lock span. I mentioned earlier that the span is automatic when it is usually set to cover all temperatures between the lowest and the highest in one image. This camera doesn't support setting it by hand. However, lock span is the ability to take a look at one scene so that the span automatically sets to this scene, and then we lock this and we look at a different scene with the same span. Now, this is useful in case we want to compare visibly similar but thermally possibly different cases. For example, we are at a switchboard and we are looking at one RCD that we tested previously and we know it is good. So we look at it thermally and we lock the span, and then we go through the switchboard going from RCD to RCD, and in case any of them has bad contacts so that it will heat up. Now, with this locked span, it is certainly going to show up on the camera. However, if we didn't lock the span, it might not show up since the span automatically expands to the new temperatures in the scene. So the locked span is particularly useful for comparing items between themselves, but it can also be used to shoot, let's say, a scene with very narrow span, and then use this narrowed span in a different scene to improve the resolution in this temperature range. Now, the camera has Bluetooth connectivity. It can be connected to the Android app, which is particularly useful because it has really small internal memory. There is only space for 20 images in the camera alone. But with the app, it can automatically send the image immediately as it is shot. So you shoot the image and you immediately get the option on the screen to share this image, and then this image never gets saved to the camera at all. It is sent directly to the phone, and therefore it doesn't take up space on the camera. Now let's look at the special functions in this camera that are available. The first one may be pretty obvious, but it is not. The camera contains the image browser included in the firmware, so that one can always look at the images that are already saved in the memory. There is a flashlight available. The images can be shared via Bluetooth to Android app, as I mentioned. And this app, which is free, it can be used to edit images, to log temperatures, and for some basic reporting. We'll return to the app in a minute to take a closer look at it. But first, let's look at the applications. Here are some examples, and you will notice that they are all somewhat small things. This is because the camera with smallish resolution has trouble looking at, let's say, at a larger scene, and so that everything would remain clear. And therefore, the examples of unsuccessful inspections with these cameras can be, let's say, PCBs, fuses and RCDs, contacts, motor bearings, devices, particularly their supply cables. The plumbing inspection, I mentioned valves earlier, general troubleshooting or service troubleshooting. Uh, We recommend combining this camera into sets with other Metrel instruments because it is really general purpose. It can be used alongside almost any of our other instruments, from installation testers to the portable appliance testers, uh, maybe even in some service work. And as I mentioned, it can be a priceless asset for any troubleshooting. In case any of other of our instrument sense a problem, measure a problem, the camera can be used to locate this problem. The Now for the Android app, the Android Metrel IR Analyzer app. Uh, Firstly, it is used to transfer images from the camera MD9910. It can be used to start the image shooting from the phone. So you set up the camera somewhere and you use the phone to initiate the shoot. You press the button and the camera makes the image and sends it immediately to the phone. In similar sense, you can set up the camera to be monitoring some changing temperatures, and the application can be used to log them immediately to the phone. The camera doesn't have any logging abilities, but the application does. The results can be a screenshot directly from the app and saved as images. Any results we get can be commented. We can add comments to them. There is a much more versatile and easy to use image browser. And finally, simple PDF reports can be created with either images or logging results. Generally, the application is intuitive and simple to use. We really recommend it to any owner of the camera, particularly since it's free. MD9930 thermal camera. I call it our flagship, even though in the whole spectrum of cameras in the market, it is somewhere in the middle. However, it is very useful. It has very wide applications already and some professional level features. So yes, in Metrel terms, this is our flagship. It is a high quality camera with powerful firmware. It too has this very fast thermal refresh rate of 50 Hz, which makes it nice and non-stuttering for use. The thermal resolution is 120 times 160 pixels. And this is a thermal resolution that is particularly useful in industrial setting, in industrial locations, because it can already shoot multiple, some larger switchboards or larger machines, larger motors. These are the typical applications that can be very successfully shot with this camera. Similarly, the temperature range of -20 to 350 degrees is the range of typical machines or motor bearings. However, it is too low for possible furnaces, which are also quite typical in industry. The thermal accuracy is the same as for MD9910. It is plus minus 2 degrees or plus minus 2%. However, this camera has already multiple parameters which can be set to improve accuracy. The first one is obviously emissivity. The second one is the reflected heat. And if we're still not happy with the achieved accuracy, there are additional parameters available in the PC software. Field of view is 25 degrees times 19 degrees, which is on the narrow side for this size of thermal resolution, which means that very small things will be able to be resolved. So spatial resolution of 2.78 milliradian is very good for this price range of the camera. Spectral range, again, is the full IR spectrum of 8 to 14 micrometers. The focal length is slightly bigger than for 9910. It is 9 millimeter. There is digital zoom available up to 32 times. And the focus is settable manually. I already talked about why this is good, but this is a bit more of a professional feature. It is there are chances that the users will not set the focus correctly, and the focus is one of the very few parameters of the IR image which cannot be fixed in post-processing. It has to be set correctly already when shooting the image. Now, the visible light camera available in MD9930 has a 5 megapixels resolution, and it has slightly wider field of view than the IR camera, which enables the two images to sit one within the other. This is called image in image, and it is very natural because the two cameras have different field of views, and there is no additional processing necessary to achieve the image in image, so that the refresh rate of the screen is not affected by this setting. There is another fusion view where IR is slightly transparent and overset over the visible light view. And both these fusion views, where both IR and visible light image are available on one screen, are meant for easier identification of the scene or easier identification of the item that we are shooting. Simply, we are much better at understanding the visible light image. So the combination of both IR and the visible light gives us the most information that we would want. Again, the display resolution is 240 times 320 pixels. As I mentioned earlier, the reflected temperature or reflected heat can be corrected manually. So you measure it and you put it into the camera so that it corrects for it, and you have the more accurate temperature measurement. There is the laser pointer available, so that it points directly where the central crosshair of the camera is, so where the central temperature measurement is. The camera can be connected to PC over USB or over HDMI. It is saving the images to SD card, so there is no problem with a limit of space on the camera. And the PC software is part of the standard set. The special features in this camera are quite more numerous, quite more special than in the 9910. The first one is screening for fever. This is a special software function which narrows the temperature range of the camera to only to be only able to sense the temperature close to human body temperature. It goes from 34 to 42 degrees. And in this narrow range, the camera is guaranteed to achieve accuracy of half a degree. This is good enough to be able to screen for, like, if you have a large group of people, you are able to tell which ones are in the range of higher temperature. It is not good enough to actually measure the human body temperature, but it is good enough to single out people with possible fever so that they can be measured more accurately. There is alarm available when the scene reaches some limit temperature, so there is the high limit alarm. And this can already be used when screening for fever. You set the alarm to, let's say, 37.3 degrees or something like that. Uh, and whenever the camera finds someone with higher temperature than that, it will beep. The alarm is also useful when monitoring any kind of heating elements or anything else that shouldn't go over a certain temperature. Uh, there are emissivity tables already available in the camera. I mentioned earlier that the emissivity can be looked up in the tables. So when you have some unit, you know the material of that unit, and you set the emissivity for this material directly in the camera, and you have much more accurate temperature measurement for this measured unit or measured item. The camera supports shooting thermal videos with audio commentary. Now, this is useful for any situation where otherwise multiple images would have to be taken. Let's again take the switchboard as an example. If you want to have the whole board a shot and you want to have some good resolution on it, you have the option of taking multiple images that are one next to the other and putting a careful commentary to each so that you know what you shot. Or you can use a thermal video and audio commentary, and you just flow through the switchboard and comment with what you are shooting, which RCD or which fuse you have in the screen right now. The integrated image browser in this camera is already quite powerful. It is quite easy to navigate through a lot of images. The camera supports some degree of remote control with USB. So from PC, using the USB to control the camera. And the HDMI output can be used for, let's say, presentations. So it is used to project the image from the camera to the projector, to the big screen, and to the display, to the other display of any kind. So applications. The first one, this camera is good enough, its firmware is powerful enough that it can be said that it actually measures temperature. It doesn't just sense heat, it doesn't just compare areas of higher heat to areas of lower heat, but it actually measures temperature in degrees. I put here the battery checking in electric cars. Now, this could be done with smaller camera as well, but the larger resolution enables faster and easier work with easier identification of any hotspots, any weakened contacts, any weakened cells. It can be also used for troubleshooting in solar plants. Now, Cameras with particularly high resolutions can be used to look for actual problems in the solar panels, in the arrays. However, we consider this resolution that we offer slightly too low to be able to be really useful for solar panels. However, in solar plants, it can still be used to look for any contacts that need exchanging or continuity of the wires. With HDMI output, it can be used for demonstration giving with a big screen, and it is useful for all the applications already mentioned with MD9910. So this camera really expands upon the applications of the smaller camera. Now, I have gotten a lot of questions about what makes this camera special, what are its advantages, or why does this competitor sell such a similar camera at a lower price. Uh, Now, here I counted out the most important advantages that we have over competitors. The first one is the 50 hertz thermal refresh rate. Again, I can't stress enough how important that is, how much easier it makes for the camera to be used. Now, the manual focus. As I said earlier, this is already a professional feature. This is not a feature that is typically found in cameras in this price range, and it might be sought after because of that. Similarly can be said about thermal videos, and particularly the ability to add audio is quite uncommon. There are two variations possible of merging the infrared and visible light image, which I talked about earlier. And again, this is uncommon. This is an advantage. The PC software is part of the standard set and does not need to be bought separately. The setting of level and span can be done manually, which again is more of a professional feature and it really sets this camera apart. Uh, for more details, we have comparison tables prepared, some comparison tables prepared that you can ask for, and we will send them to you. Let's talk about the software for PC, the Metrel IR Analyzer software. Its most important, its main application is transferring images from MD9930 over USB or using the SD card so that you have them on the PC and you can process them. You can manage them in the image browser. The images can be edited using modern thermographic tools. By that, I mean everything from the most essential editing, like cropping or changing the level and span, or changing the palette, to the more scientific, to the more thermographic editing, like changing the humidity of the air that we shot in, changing the distance that between the camera and the shot objects, and so on. So we have additional parameters here that can be changed to again achieve higher accuracy in temperature measurement. The measurements that can be added are mainly in form of points. So you can point to anywhere in the image and see the temperature that was measured there. There can be lines so that you can look at temperature differences over some distance in the image. Or similarly, this can be done using the area measurement. The results, again, can be commented, the comments can be added to them. And finally, the results that we got from this post-processing can be used to create custom PDF or XML reports. The reports contain the IR image, the visible light image, the measurement results, and any comments that we added. While on the front page, the title page is custom and can be changed as the user desires. So for the last instrument in our thermal line, MD9880 is a combination instrument. It contains a thermal viewer and the multimeter. Now you will notice that here I'm using the word thermal viewer because this is not a camera. It does not have the memory and it cannot shoot images, it cannot save images. However, it can show the thermal view on the screen so that wherever you go, you can only look at what is on the screen and use that. However, this thermal viewer is on the level of MD9910. It has a similar resolution, a similar fast refresh rate, similar field of view and spatial resolution, similar display size. The only real difference is the temperature range, which is slightly smaller. Again, similarly to MD9910, it has a fixed focus. And to stress again, there is no memory in this instrument. It can only be used to view the heat in the scene. The multimeter functions are TRMS AC and DC voltage, TRMS AC and DC current, the resistance and continuity, capacitance, frequency, and diode test, which are most commonly used multimeter functions. And accuracy of all of them is again acceptable for the general purpose applications. So applications of this instrument, I see the most powerful application for this instrument in troubleshooting and service work. It can be used to locate problems with almost any device out there. It can be used for essential electrical and thermal testing in any environment. But I would like to stress its ability to work in electric cars or electric vehicles in general. The thermal view can be used to locate problems like bad connections, failed continuity or something like that are underneath the metallic plates of the car. It can also be used to search for any damage or any exhaustion to battery cells, maybe particularly for any higher output resistance than it should be. It can also be used to find spills of oil or possible water ingress. Then the multimeter can be used to check the presence of voltage on the battery or at any point in the car. It can be used to measure resistance of the contacts. The capacitance measurement can be used to check for moisture and similar. The multimeter and thermal view so complement each other in diagnosing the source of the problem. Now, I made an example of electric car, but this is true for almost any environment. The multimeter is also very small, very practical. It can be carried in the field or it can be used in the workshop. So before we finish, I would like to talk a little bit about available materials that we have apart from this presentation. You probably already know about the single leaflets and the user manuals, which are available on our webpage. But there's additional information available in the catalogs, particularly in the industrial catalogs, in application notes, and the video that you already viewed at the beginning of this presentation. Then I mentioned the comparison tables. They are available per your request. And if you have any specific competitor or model in mind that you would like us to include into comparison tables, please write to us and we will add them.